Will I pull up the answers? Where are they? See, I don't even have them on here. .3 worksheet 1. Alright, so this is what your graph should look like for 4 and 5. The darkest region should be the bottom part. Number 5 should be the darkened region in between the two lines. Now 5 and 6 were basically the same slope and y-intercepts, but you'll see that the shading is different because the one symbol was a greater, both of them were greater thans and a greater than or equal to. So the overlap should have been in this region. And then 47, we had a linear function and we had an absolute value function. It should be this little triangle shape off to the side. And then on the back, we were writing our inequalities to match. You can see mine didn't scan very well, but y is greater than or equal to negative 2x plus 2, and y is less than 3x minus 2. If you have those in a different order, that's okay, because I don't think they were numbered L1 and L2. Oops. Make sure for the vertical one here that you did have x is, and I believe it was shaded this way, so less than 1. And then our multiple choice, it said check all the that apply. So is this point a solution of this graph, or this graph? We should have picked A and C for 30, A and C for 32, and A and C for 34. And you did have to picture for this one, going off the graph, how it would show up. If you wanted to also, since this one went so far off the graph, you weren't sure if maybe it did fit in, you can plug in x, negative 15 for x and positive 15 for y to check them algebraically instead of graphically. So today all we're going to do is add in word problems, and then we are going to see some where we're graphing more than 2. So on the back we'll have a word problem. We're going to have to write, I think, 4 inequalities and graph all 4 and find where the overlap would be. And that's actually going to set us up for the section we'll start after our quiz, which is linear programming, where we'll be graphing a lot of different inequalities at one time. Now to save us some time today, I did label our axes for us, and I also did put the lines. So when we're solving real world situations, we can graph linear inequalities to solve them. And when we graph them, again, sometimes we'll be counting by different units on the x and the y axis. So you do have to determine a scale oftentimes. In your homework, you'll have to come up with your own scale. You can use your x-intercepts and the y-intercepts to determine the scale that you would need. Because the x-intercept would be the highest value you need to get to, and same with the y. Remember, to find the intercepts, okay, the y-intercept occurs when x is 0, and the x-intercept occurs when y is 0. So you just plug in 0 for both of the variables and solve it out to get the intercepts. Now we will also have to write the system of inequalities. And they did define variables for us. They also want us to identify 2 possible combinations that will fall in that overlapped region. Okay, so it says a group of friends will buy at most, so that's important, at most 8 snacks at a movie theater and spend no more than $42. They will pay $4 for each box of candy and $7 for each bag of popcorn. Write a system of linear inequalities to model this scenario, and we will graph it as well. X is the number of boxes of candy, and Y is the number of bags of popcorn. So again, it does say a system, so that will indicate that you're going to have more than one to model it. Who thinks they could give me one inequality using X, Y, and some numbers? Ashley? 4x plus 7y, not equals 42. It could be no more than 42. Perfect. No more than would be less than or equal to 42. And then how about the at most 8 snacks? Abby?
X plus y is less than 8.
Good. At most, also less than or equal to. And then to solve this, go ahead and find the intercepts. Obviously for this one, the intercepts will just be 8 and 8. And finding our intercepts for the other one, plugging in 0 for x. We'll get y is less than or equal to 6. When we plug in 0 for y, we will get a decimal there because 4 doesn't go evenly in, so we will get 10.5. And then you're going to graph and shade each of those separately, and we'll look for our overlapping region. Again, in your homework, you may have to scale your axes, and of course don't forget your labels because those are worth a point. So on the y-axis for this one, I'm going to start at 6. I will have a closed circle. And on the x-axis, I'm going to go to 10.5, which I'm going to have to go just slightly off the graph. I didn't scale that very well, apparently. And we'll put a solid line, and we're going to shade underneath that. Now, we will use a segment, actually, because we can't have negative candy or popcorn. And then for the other one, we'll do 8 and 8 are both the intercepts. So we'll have 8 and 8. Again, also a solid line. Now, if they were a dashed line, you would actually put an open circle, which we'll probably see one, maybe not, maybe on the back, but an open circle instead of a closed circle at the points. And we'll also do a solid line here. And then we're going to shade also less than. So the final solution again is where they overlap, which would be in this region. And if you only want to shade this region, this is really the solution. So if you don't want to shade the other part, some students don't like to, you don't have to. Then they want us to pick 2 possible combinations of popcorn and candy. You can pick any ordered pair that lies in the shaded region. Who can give me one possible combination of the number of boxes of candy and popcorn they could afford? Abby?
1 box of popcorn and 4 boxes of candy.
1 box of popcorn and 4 candy, yes. I guess those bags of popcorn, whatever. That's fine. And another one. So that's where she picked hers. Garrett?
2 boxes of popcorn and 5 boxes of candy.
Good. Any ordered pair that falls in there would work. All right, the next one is a little bit different. It does talk about a little bit of area, I think, or perhaps perimeter, actually. You would like to fence a rectangular garden. So first of all, you might want to just draw a little rectangle to help you figure this out. The length of the garden should be at least 80 feet. And the distance around it should be no more than 310. So again, we need to interpret the distance around it. That means the perimeter. Okay, which we can use a formula for, or we can also just add up the sides. What are the possible dimensions of the habitat? Define variables, then write and graph a system of inequalities. So So we know that there are two variables in a rectangle. There's the length and the width, and we know that they happen to match up because the rectangle has opposite sides that are congruent. Now it's up to you whether you want to use L as the variable that we're going to graph, or if you want to use X and Y. It doesn't really matter as long as it's an unknown. I think I'm going to use L. So the length, which would be L, needs to be at least 80. What inequality symbol is at least? At least. This is the one that some students get confused with. Ashley? Good. At least is actually greater than or equal to. That's actually one of our inequalities. It's going to be either a vertical or a horizontal line with shading, depending on how we have our axes labeled, just like if we had X or Y. Okay? Because that's what this says. The length should be at least 80. And then it says the distance around it should be no more than 310. No more than 310 would be what inequality symbol for no more than? No more than. Awesome?
Less than.
Less than or equal to. Now the perimeter, you can either add W plus L, or if you remember 2L plus 2W is the formula for perimeter. And that should be less than or equal to 310. So those are the two inequalities. Now we just have to graph them. Now I've already labeled the axes for us. I let the x-axis be the length. So this is really like x is greater than or equal to 80, if that helps you. So that's going to be a vertical line at 80. It will be solid. Oh, let's go in the wrong direction. And then which way am I going to shade? On the left-hand side or on the right-hand side of that line? So we want greater than or equal to 80. Caleb? The right-hand side. Where are the x values greater than 80 on this side? Now for the other inequality, we do want to find the intercepts, would be the easiest way to do this. So I would actually plug in 0 for L and 0 for W. Whenever I plug in 0 for W, it just kind of goes away. So we'll get 2L is less than or equal to 310, and 2W is less than or equal to 310. So both of them are going to get the same intercept, which would be 155. So we're going to plot points at 155, 40, 150, 155. And again, you are estimating a bit in between those coordinates. This one also gets a solid line, but this one we're going to shade underneath. This one we'll use a segment because, again, we can't have negative. And we're shading underneath that. So our final overlapping piece is this triangle shape. Looks like a right triangle. So the possible dimensions are any that fall in this region. So the length could be 100 and the width could be 20, or the width could be 40. Any ordered pair that falls in between there. This solution set represents all of the possible dimensions that could exist. All right. On the back we have the harder one. We're going to be graphing 4 different inequalities and looking at where they all overlap. So there's going to be more bounding going on than just 2 lines. And also the harder part will be writing it. So I'm going to read through it, and then I think I'm actually going to let you guys pair share for a little and see if you can come up with the inequalities, because that's the hardest part. If I tell you what they are, it's an easy question from then on. But coming up with them is the hard part. I will define variables with you first. So it says the I'm guessing that says entrance exam has two parts to it, a verbal part and a mathematics part. For admission, the school of your choice requires a math score of at least 550 points and a total score of at least 1,100 points. You can score up to 800 points on each part. Write and solve a system of inequalities to model scores that meet the school's requirement. All right, so based on the way that you can see that I already set up the graph, I'm letting X be the verbal score. So let's just jot that down. So that's the score you're going to receive on the verbal portion of the exam. And I've let the Y equal our math score. All right, I'd like to give you about 60 seconds. I want you guys to read through, see if you can write. You're actually going to write 4 different inequalities to model the words that we see. Then we're going to pair points. A math score of at least 550 points. So what inequality did you write for that? Ashley?
X is greater than or equal to 550.
Perfect. They don't always have to have multiple variables or numbers. Sometimes they're just going to be vertical or horizontal lines that are going to bound the region. Oh, wait. Y is math. Ash. That's okay. I saw your faces. Y. Okay. Math is at least 550. A total score of at least 1,100 points. Sam?
X plus Y is greater than 100 points.
Yes. Total score, which is math, verbal plus math, and that's at least greater than or equal to 1,100. You can score up to 800 points on each part. Because if we were just to graph these, it would look like you could score like a 5,000 on the exam. We can't if we were to shade them. So what would I write? I actually can come up with 2 inequalities for that. Caleb?
X is less than or equal to 800 and Y is less than or equal to 800.
Perfect. We have to bound both the X and the Y by the max score that you can get on each part. And then from here, you're just graphing them. Now, it looks like we're going to go off the graph a little bit. Nice job, Mrs. Bennett. Okay. The 1,100 is going to go like one row above. I don't know. But the first one would be at 550. We would have a solid line. Y is our math score. So 500's here, 550's there. That'll be a horizontal line. And I would shade super light because you're going to have 4 overlapping regions. Some of you will prefer not to shade until the end, and that's okay. You don't have to shade as you go if you don't want to. So greater than or equal to 550, so that's going to be up here. All right, then we have, again, our X and Y intercepts for this one will be just X is greater than or equal to 1,100 and Y is less than or equal to 1,100. Now, when you find the intercepts, some students will start graphing horizontal and vertical lines at these points. Remember, these are your intercepts. So you're just plotting a point at 1,100, which would be like up here, and 1,100. This is a slanted line. If you were to solve it, it would be Y equals negative X plus 1,100. Also get a solid line here. And this time again, we're shading greater than. Now, personally, as I shade with these, I won't shade this whole thing. I'm only going to shade where they overlap, just so I don't have to get confused later, because we're shading greater than this part, but the only possible solution is where they overlap. So I would probably just shade up there. I'm not going to shade the part down there. And if you want, you can erase as you go, which some students will like with the 4. So if you want, you could erase this part over here, because it's not going to be part of our solution since it doesn't overlap all of them. You're not required to erase, but some students find it can help. Then we'll graph each of the other ones. So we have x is less than or equal to 800. So this is going to be a vertical at 800. So we'll go to 800. Let's pick green this time. And we're shading less than. So the less than part would be over here, where the values are smaller. Again, I would only shade where they overlap, which would be in this region. And if you want to erase, you can erase this portion. And lastly, we'll do a horizontal line at 800. And we're shading also less than. So our final answer should be this shape right here. Which is a trapezoid, actually. Not that that matters. A lot of them are going to be bounded with horizontal and vertical, and even when we get into our next section, we'll end up maximizing and minimizing cost and profit functions, but our graphs will look like this. And then they ask us to find two possible scores that would satisfy the school's requirement. So you can pick any ordered pair that goes in here. Who thinks they could give me one pair of verbal and math scores that would satisfy? There's lots of them. Garrett?
600 and 700.
600 and 700. Good. Who could give me another one? Again, when you give me these answers, I'll have to check them, everyone, because there's so many possibilities. They don't have to be whole numbers. You could be like, oh, I could get a 721 and a 721. Be creative. They don't have to be whole numbers. I mean, not whole numbers, but 5s and 10s, etc. All right, then I'm going to give you guys the rest of class to work on your homework. Again, your quiz is on, let me try a whole bunch of it today. You will need to label your axes with a unit and also determine your scale, which will make them take a little longer than the ones on the board because we already have that written out for us. There's only 3 homework questions. If you guys want to move around and work together, you are more than welcome to. Tomorrow we'll do a partner challenge and we will do our review.